Now let's look at the last example problem for this topic. It's a LeetCode hard problem called maximum frequency stack. So this problem is optional in the sense that even if you don't fully understand what we talk about in this problem, how to solve this problem, it doesn't affect solving the problem set. But I think it's a very interesting problem, and it illustrates usages of set and map. So to understand the problem, we first need to know what is a stack. So stack will be covered later in this topic, but I assume most of you have some familiarity with the stack, and also the understanding of stack that are required for this problem is really not much. So we just need to understand the basic for stack in order to solve this problem. So a stack supports two operations, push and pop. The main condition is, so push will add a value into the data structure. Pop will get one of the previously added value and return it. So the constraint is that the pop will return the value that is added most recently. So for example, if we have this sequence of operation, push 2, push 3, push 2, push 1, then the first pop operation will return 1 because that's the last added element. And the next pop operation will return 2 because this pop get rid of the last one. So then 2 becomes the most recent added element. So after this pop, the stack just have 2 and 3. Now if we have another push 3, that 3 is added to the end. So the stack become 2, 3, 3. And the next pop will return the last 3. And you should be able to tell what the next pop returns. The answer is 3. And at this point, the stack contains a single item, just 2. So that is a stack. This problem asks us to implement a maximum frequency stack where the pop operation will return and remove and return the most recent addition of the value that has been added the most number of times. So it's not simply based on the order of adding to the data structure. The first priority is based on frequency. We want to get the item that has been added the most number of times in the data structure. So basically, remove the most frequent item. And if there are 2 items that are equally frequent, then we will remove the one that's added most recently. So to illustrate that, suppose we have this sequence of operation, push 5, 7, 5, 7, 4, 5. So at that point, you can, if we view this as a stack, this is what we have, 5, 7, 5, 7, 4, 5. But if we start popping at this moment, the order is not just going backward. So I try to use the highlighting color to illustrate the order so that the lighter ones will be popped first. But it doesn't work that well. So first you should think about, well, what will be the sequence of values if we executing 6 pops after this. So the 6th element will be removed and returned, but what is their order? So the order is, the first one that is returned is the 5, because 5 appears 3 times, and that's the most frequent item. So the first element that is returned will be 5, and after 5 is returned, this stack has 2 occurrence of 5, 2 occurrence of 7. But since the most recent, the last added element between 5 and 7 is this 7 here. So the next one returned is this 7. So after that, the next one returned is this 5, because this 5, at this point 5 appear twice, so it's the most frequent. So after the first 3 pop, the stack becomes 5, 7, 4. Every element appears just a single time. So then the pop order will just be the normal order of reversing. So 4, 7, 5. So the popping sequence will be this. So now the question is, how do we implement it? Again, let's start with the brute force method. We just use a dynamically sized array to store the elements that have been added. So then push is efficient because we simply need to add it to the end. For pop, we need to scan through the array, count the number of appearances of each element, and find the element that appeared the most number of times, and remember the last appearance of it. So essentially, we'll be scanning backward from the end of the array. We'll be keeping track of 3 information: the element that appeared the most number of times, and the last appearance, which actually the first we will see of that, and also which element is it. This will take time linear in the array size because we need to scan through the whole array in order to decide which one is the most frequent. So that's not efficient enough. So this is take 2 of another approach of solving this problem. It turns out that this is not the best solution. So there is a very elegant solution. But this take 2 solution, it's sort of important in the sense that it's a natural way of using basic data structure. It doesn't use any extra clever insight. It's sort of just the following based on the requirement. We can deduce what data structure would work, and it will have a reasonable implementation that's reasonably efficient. So the main problem is we need to quickly find the element that appeared the most number of times in order to make pop efficient. So then obviously we want to find the most, then we can use an ordered set to achieve that information. So we can use the ordered set so that every element is in the set is 2 things: the number of occurrence and the corresponding element. So then given a set of this pair, or you can view this as a pair, or you can view this as an array of 2 elements, but these let's call it the pair. Given this pair, if we have an ordered set, then the last element will have the most number of occurrences. However, we still need to do type breaking. So if we have 2 elements that appear the most number of times, we want to be able to find out which one appeared, which one have the most recent appearance. So since we are already using a set that provide order to us, we might as well taking advantage of that set to also put in this information, this order information, so that the selection from the set will be the right one. So in order to do that, we can use a counter to essentially count how many push operations have been performed. So then every push operation will have a sort of a counter value associated with it. So let's call that time. So this is every push happens with a new sort of timestamp. So then we can put in the number of occurrence of a number, the value element, and also the time of the last addition of that element and the element. We can have a size 3 array and put that into this ordered set. And then when we take the last element from the set, it will have the most number of appearances. And if there are multiple elements have the same number of appearances, then it will give us the one with the last addition, so which is exactly what we need. Okay, so we need this set to be able to support finding the element. Now, after pop, we need to update this this set. So actually, this should be an ordered set. So how do we update this ordered set after the pop operation? So then we need to we'll remove the last element, but then we will need to add another new element into the set corresponding with the next occurrence. So for example, after we did the pop and this 5 is returned, we want to put in the set information that 5 now appear 2 times, and the most recent appearance has a time 3. So we need to put that into the order set. So that means we need to find out what is the previous occurrence of 5. So that means we need to store all the times of push for each element in another data structure. So then we need 2 data structures. One is an ordered set of triples, the frequency, last addition time, and the value. And the other data structure will enable us to find for every element store the list of the time of that element being added. So what data structure should we use there? I think the should be pretty. I hope it's obvious that one way to do it is to use a map that map each element to an array list, to a list of addition time. So then after popping, then we can, from this array list, we can find what is the last value in this array list, and then create a new triple for the element and add it to the order set. So also essentially popping will remove the last time and then use the previous one. So how do we support the push? So when push happens, how do we update the 2 data structure to remember necessary information? So recall that the 2 data structure is one ordered set of triples and one map of value to list of addition time for that value. So updating this map is easy because when we push this new value, so given x, we can find the list and then simply append the current time at the end. So update the set is a little bit more complicated because now both frequency and the last addition time for x changes. So the triple in the set corresponding to x will need to be updated. So the way to do that is we can find the element, remove it, and then we insert a new one. So because of the map, given x, we have enough information to determine how many times x has been added and what is the last addition time. Because we simply find the array list corresponding with x in the map, and then the length of the array list will be the frequency of x, and the last value in the array list will be the last time. So given x, we can reconstruct the triple and then tell this have this set remove that triple, and then we can add a new one which can also be easily computed. Basically frequency will increment by 1 and the time will be the current time because this is when the push occurs. So here is the Java code for doing this. So we have 2 data structure. So data is a tree set of interarray. So each of the interarray is have 3 elements: the frequency, the last time, and the value. And then there's a hash map which will map each value to a list of indices. So here the index means the timestamps. Yeah, and we need use this. This is our time sort of time counter. So when we the constructor will create the map, and here we pass in this our comparator, which compare integer arrays element-wise. So I find this comparator is very useful. So I use that for solving many problems. So this is the code for the comparator. It compares two integer arrays. It compares them element-wise. If based on the first element, I can decide which one is smaller, I use that. Otherwise, compare the next one. If the first element is the same, compare the next one, and so on. So this is the pop function. From the order set, we take the last one. So this is the one that have the most the highest frequency. So when I use the array for this kind of recording different kind of information, I generally have a comment in my code to indicate what are the different elements of the array are, and this will help me write the other code. So given the value in this, this v will be the value that we popped, but we still need to update the data structure to maintain information. So we get the corresponding array list, and then we will remove the last element in the array list. And after that, we will check whether there's more than 0 added time. If there is, we will add that into this. Into this order set, so that this can become a candidate for being removal. So the size is the size of this list after I remove that, yeah, this is the time for the most recent addition. So that's the pop function. The push function we'll first try to get the array list, so the list of addition timestamps from the map. If it does not exist, we'll create a new list and then put this at the time. Then there are two cases. Case one is this is the first time this X has been pushed. So in that case, then it's easy. We just need to add this into the array list, and then we will add this new value. However, if X has already been added before, this is the second or the third or even more time it's added, then we need to remove the entry for the value X in the from the order set. So we need to figure out what value that is. Construct this 3-element array and then remove that from the order set, and then we add the count, and then we add this information to the set.